Hey guys, it's Ethan. We'll be talking about thermite and types of chemical reactions. Thermite is a chemical composition of a metal and a metal oxide. The thermite I will demonstrate consists of aluminum and iron oxide. I will use this demonstration to talk about the differences between endothermic and exothermic reactions. There are two types of reactions, exothermic and endothermic. An exothermic reaction gives out energy into its surroundings. An endothermic reaction takes in energy from its surroundings. Every reaction has an endothermic part and an exothermic part. In the reaction, 2 hydrogen plus 2 chlorine yields 2 hydrogen chloride. The endothermic part of the reaction is when the bonds between hydrogen and chlorine break, creating individual hydrogen and chlorine atoms. It takes energy to break the bonds. You can think about it like breaking a pencil. It takes energy to break a pencil. The bonds have to break so they can rebond into a new product. When you break the bonds, you will have 2 free-floating hydrogen and 2 free-floating chlorine. The reaction has become exothermic when the hydrogen and chlorine atoms bond together to produce heat and/or light. The endothermic reaction that causes the original bonds to break makes it possible for the exothermic reaction to occur. When the energy absorbed from the endothermic part of the reaction is greater than the energy released in the exothermic part of the reaction, the whole reaction is called an endothermic reaction. When the energy released is greater than the energy absorbed, then the reaction is called an exothermic reaction. As you can see from the graph, the amount of energy released is greater than the energy absorbed. So this complete reaction is exothermic. Let's take a look at the equation for the thermite composition we will be using. As you watch the actual reaction, decide if it is an endothermic or an exothermic reaction. Now the part you've all been waiting for, the reaction itself. I'm about to do my thermite reaction. This is my iron oxide. This is my aluminum. I mix these together to make a composition. The composition ratio is you have to do it by weight. It's 2.7 to 8, with aluminum being first. And as you can see, this aluminum is a silvery color like you see in aluminum foil. And then if you didn't know this, iron in its natural state is red, even though like cast iron you see is like silver. Because as you can see, it's completely red, because the bag is coated with it. So I'm going to make a composition for my reaction, and then I'm going to put a magnesium strip in it, because that's the amount of heat I need to debond the atoms, because that burns at about 3,000 degrees, and that's around where the heat that I need it to be to start the reaction. Hey guys, I'm about to film my thermite reaction. Let's flame on. Come on. As you can see, it's creating a chain reaction where it's igniting more thermite. Or maybe you can't see. As you can see over here, the molten iron has stopped, the thermite has stopped reacting over there. Mesmerizing, isn't it? Just to show you how hot it gets. Look at this stick. Instant flame. Guys, instant flame. So you do not want to mess with thermite. Look at that. That's just how hot it is. So this is molten iron and molten aluminum oxide. But this reaction got hot enough to melt. See what happens if you put a leaf on it. Look at that, instant flame. So do you think the reaction we just witnessed was exothermic or endothermic? It was an exothermic reaction. More energy was released than absorbed. Once the bonds between the aluminum atoms and the iron and oxygen atoms were broken by the heat of the magnesium, then the oxygen atoms violently bonded with the aluminum atoms, releasing a large amount of energy. This energy broke more bonds, resulting in a chain reaction. Just to show you how much energy was released, this is a solid sheet of aluminum, and this is the hole that thermite made in it, that the thermite made in it. And here is here's the iron and aluminum oxide that was made from our thermite reaction that you saw. So underneath this oxidized outer layer, and you see that's black, and you were thinking, well, that aluminum's shiny. Why isn't that? Because that carbon layer on the outside makes you not be able to see the metal. So this is a scrap of metal that I've polished, and that there is what it would look like if I polished that whole thing.